So, okay, so recording has started. Today is September 16th. Happy Wednesday, halfway through the week. We're making our way. The plan for today is go over checkpoint quiz 1A. If you turned it in on Teams as of yesterday afternoon, I got back to you and gave you some feedback. If you turn it in after that or doing it in packet, I haven't given you feedback yet because you haven't turned in the packets, or I just haven't looked at the newest quizzes that were turned in. So we're going to go over that. We're going to begin lesson number 6. And then for those who have a computer, we're going to start iReady. The target for today is to apply understanding of factor pairs to explain if a number is prime or not. We've been working with factor pairs. We've been working with multiples all the last week plus. So we're going to apply our understanding now of those factor pairs to help us determine if a number is prime or not. We probably won't get through the whole lesson, and the homework is very closely tied to the lesson we are going to do in class. So it is very important for you today to follow along with the diagram that we are making to help you understand what's on the homework. Okay. Homework for today, assigned yesterday was the hot dogs and buns one. That's due tonight at midnight. And then we have a new assignment today, an open and shut case that is due tomorrow night at midnight. Okay, so let me stop sharing that. Let's get my notes up. Okay, I'll share my screen. Okay, let's let Daniela back in. Okay, so you should see this 4.1.8 checkpoint. Let me make sure let's make sure that we're muting our audio. Sorry, I have to let Juliana in. I'm going to mute everybody real fast, and then I'll get my notes back up. There we go. Okay, so looking at this quiz here, like I said, I gave you feedback if you turned it in yesterday before 2:30 or 3 or so, because I had them all graded by about 3:30. So check your feedback there. I'm going to work through these with you guys, or for you guys, really. I'll get some feedback here and there. If you have questions, please ask. But I want you to check your understanding here. Okay, so going through each of these, please raise your hand if you have a question or want to talk about something. So this first one here, we've been talking about finding area of rectangle for a couple weeks now. We talked about rows and columns and how we can use the number of rows and columns to our advantage to help us find the total number of units inside. So in this rectangle here, I see 4 columns, I see 3 rows. So I can take that 4 times 3, each of the side lengths, to give me 12 square units inside. Right, you can take one side length, multiply it by the other, and get our answer. Giovanna?
Didn't we already do this for like tests?
Well, yeah, so this was the quiz. I'm going to go over it so you can see the answers, fix your mistakes if you had them, and because I'm not going to score the quiz. I looked at it, and I gave you feedback if you turned it in on Teams. I'll give you feedback if you turn it in on the packet. But I wanted to spend some time as a class looking through it, make sure that we all had the right answers and right understanding.
Oh, okay.
Yeah, so we're just going to quickly go through this. Yep. Okay, so that was the first one here. What is the area of the rectangle? It is 12 units. How do we know? Well, we took each of the side lengths and we multiplied them together. Had 3 rows, 4 columns. 3 times 4 is 12. Okay, what are the possible side lengths of a rectangle with an area of 10 square units? Draw an example of each possible rectangle on the grid. Well, when we're trying to find the possible side lengths of a rectangle and we know the area, we are basically just finding the factor pairs for that area, right? We're finding the 2 things that can multiply together, that factor pair, to give us the answer or an area of 10. So as we've done before, we start with 1 with our factor rainbow, and we connect it to the area or the number that we're trying to have as the product. So 10 square units is what we're trying to end up with. 1 times 10 is 10. We then, after trying 1, we go on to 2 and test out 2. Well, if we skip count by 2, that's actually the same thing as 2 times 5 would get us 10. And if we skip count by 2 5 times, we'll get 10. So there's another factor pair, 2 and 5. Daniela, are you having tech issues or do you have a question?
I can't see you. I can only see Joanna.
Okay, Giovanna, Stephanie, can you see my notes that I'm doing? Yeah.
Yes.
Okay, Daniela, log off.
The pin. Maybe because,
What's that, Stephanie?
Maybe because when you touch a person, it tells you pin, and then when you have to press the person again who, like Giovanna, that she had to put pin.
I didn't put pin. I was just looking at the screen, but then it turned to Joanna.
Okay, well, Daniela, try exiting the call and coming back in, and I'll let you in and see if it helps. Okay, so we have 1 times 10 as one of the options. We have 2 times 10 or 2 times 5 as another option. We could test out 3, we could test out 4, but those are not factors of 10. So let's go ahead and draw our rectangles. I'll do the 1 by 10 first. I think that was 10. 10 rows, 1 column. You could also do it the opposite way too. And then we have 2 rows, 5 columns. All right, so those are the only 2 options that we had. Those are the 2 factor pairs or sets of factor pairs that make 10 square units for our area of rectangles. Okay. Let's go down to 3 now. It says select all the true statements. Okay, so there could be more than one here. So best way to work through this problem is just to go 1 by 1 and see if it's true. So A, 5 is a factor of 35. So, well, let's think about it. Can we multiply 5 times something? All right, great, Daniela. I see you say you can see it now. So that's good that you're able to see it. So looking at A, 5 is a factor of 35. Is that true or false? Well, we can multiply 5 times something to give us 30, right? 5 times some blank equals 35. That's what I meant to say. All right, we could skip count by 5, land on it. We could draw a rectangle and see if we can find an area of 35 total. But ultimately, 5 times 7 equals 35. Okay, so since 5 can be multiplied by something, in this case 7, to give us our product, our 35, then A would be correct. 5 is a factor of 35 because you can multiply something by it to get 35. Okay, so for B, 35 is a factor of 5. Well, can we multiply 35 by a whole number and get 5? No, right? We multiply 5 by something to get 35. So 35 would not be a factor of 5, but it would be another thing, and we'll get to that later. But B would not be correct because 35 is not a factor of 5. Stephanie, you have a question?
Yeah, is that on the packet?
So this is not on the packet. The second page was not included. I didn't see that it was part of the quiz. So I wanted you to do this on a separate sheet looking at the team's assignment. So if you didn't, that's okay. But yeah, in the future, I'll try to include all of the quizzes, all the pages. I just didn't see, I didn't have access to the second page, so I didn't know it existed until after I sent the packets out.
Okay.
Yeah, so just follow along right now. All right, so we said B is false. Let's go to C. 5 is a multiple of 35. Well, 5 would not be a multiple of 35 because we can't skip count by 35 and land on 5, right? We'd go 35, 70, on up, right? We totally blow past 5. So C wouldn't be correct either. Let's try D. 35 is a multiple of 5. Well, we said for this 5 times 7 here, right? These two things that are being multiplied together. We said that when we multiply two things together, they make a factor pair, right? 5 and 7 make a factor pair for 35. So 35 is the product between the two, but it's a multiple as well of each of those numbers here, 5 and 7. 35 is a multiple of 5 and a multiple of 7 because 5 and 7 can be multiplied by each other to get 35. Okay, so D would be true because we can multiply something by 5, in this case it's 7, to get us 35. So therefore, 35 is a multiple of 5. Does that make sense? Are you following along with that? You see the flow, you see the logic, the reasoning? Okay, let's move on to this. Should say 4. It says 2. It says, is 19 a prime number or a composite number? Explain how you know. Well, when we're trying to figure out if something is prime or composite, we think about the factors, see how many factor pairs there are. All right, so the easiest way for us is to make our factor rainbow. We have 1 and 19 straight out of the gate, because remember, we can at least make the factor pair of 1 and the number. So 1 and 19. We would then need to go through and start testing some numbers and see if they are factors of 19. So we test and see, is 2 a factor of 19? Well, when we skip count by 2, 4, 6, 8, on and on, we only get even numbers, right? 19 is an odd number. So we know that 2 would not skip count and land on 19. There's no chance. So 2 wouldn't work. We could try 3 and go 3, 6, 9, 12, on and on. But we wouldn't, I guess I can keep going. It's not too far. 15, 18, 21. But 19 would land right in there, and we don't land right on it. And so therefore, 3 is not a factor of 19. So that's canceled. We could try 4 as well. 4, 8, 12, 16, 20. But we skip past 19. So 4 is not a factor as well. So we would cancel that out. And we keep trying over and over and over, but the only factor pair in the end is 1 and 19. Okay, so therefore, it is a prime number. So 19 is prime because the only factor pair is 1 times 19, or I guess you could also say 1 and the number itself. Right? So 19 is prime because the only factor pair is 1 times 19, or in other words, 1 and the number itself. So I'll put in parentheses 19 for this problem. Right, that was our definition that we had. Miguel, do you have a question?
No, it's from earlier.
Okay, did it get answered or what?
No, it was because it just like one more and one less than like if you would have went like 3s or 4s, you would have landed 1 more or 1 less than the number you were supposed to land.
Yeah, so they were when we skip counted, we almost landed on 19, but we were 1 off. We're at 18 or we're at 20. Yeah. Yep, that is very true. Looks like Ariana's getting on. So get her in here. So are there any other questions on this quiz at all? Any concepts here that we covered that you're still confused on, or mistakes you made that you still need cleared up? Okay. I noticed a couple things here. I noticed a lot of people put A and C. What is A and D, right? 5 is not a multiple of 35. That's what C says. Because 5 is a factor of 35. Factors are the pairs that we multiply together to get the product. And so for A, 5 can be multiplied by 7 to get 35. therefore 5 is a factor. And then for D, like I said, 35 is a multiple of 5 because 5 can be multiplied by some number to give us 35 in the end, and that number is 7. So therefore 35 is a multiple of 5. I also saw for this last problem here, is 19 a prime number, composite number? I saw some who said, yes, it's prime, but their reasoning was because it's odd. And that's not the only thing that makes it prime, right? All prime numbers except for 2 are odd. But the thing that makes it prime is that it's the only factor pair is 1 and that number. So 1 times 19. Okay. Stephanie, do you have a question before we move on?
So is that in teams?
It is in teams, yes. But if you did it in the packet, that's fine. You just missed the second page, and I wanted you to get the second page down. So you can view the assignment in Teams and check out that second page. Okay, let's go on to our lesson here. Okay, so this is page 23 in your packet or page 25 in the workbook. Now, who can first explain to me what is a locker? Like, what are these? What are lockers for? What do we use lockers for? Where are they at? Alan?
To store stuff.
Okay, yeah. So to store stuff, we usually see them. Oh, there goes my lights again. We usually see lockers in upper grades, so like high school usually, just because at the high school level you have more textbooks and things you need to keep track of. So yeah, lockers are usually like a high school or upper class thing, so we don't really see them at Union Gap here. But yeah, I'm going to go ahead and get my highlighter out. Please follow along as we write all of these, as we underline and highlight in the instructions themselves. But I'm going to make a diagram here, and I want you to follow along because it's important for your homework, like I said. So it's important that you follow along and do the same thing that I'm doing up here, okay? Because you'll need it as a reference for your homework. So this picture shows lockers in a school hallway. The 20 students, in Tyler's 4th grade class are playing a game in a hallway that is lined with 20 lockers in a row. Okay, so there's 20 students in Tyler's 4th grade class. They're playing a game in a hallway that is lined with 20 lockers in a row. All right, and we have this diagram that they gave us here with 20 rectangles listed 1 through 20. We're going to be using that to help us keep track of what's going on in this problem. Right, just a second. I need a sip of water. Okay. So looking at this first bullet here, the first student, so I'm going to highlight that seems important. First student starts with the first locker and goes down the hallway and opens all the lockers. Now I'm going to make a quick adjustment to this. Instead of opening the lockers and closing the lockers like they said, we're just going to touch the locker. Okay, so don't try to keep track of open and close. We tried that with the first 2 blocks, first 2 classes, and I felt it really confused them. So we're no longer going to think about opening and closing, just touching the locker. Maybe like putting a Post-it note on the locker. Okay. So the first student starts with the first locker and goes down the hallway and puts a sticky note on every single locker. The second student starts with the second locker and goes down the hallway and puts a sticky note on every other locker. Okay, so only touching the even numbered one, 2, 4, 6, 8, because he's starting at 2 and going every other locker, putting a sticky note on the locker. Okay, the third student stops at every third locker It opens the locker if it's closed or closes if it's open. Again, putting sticky notes. So the third student stops at every third locker and puts a sticky note on the locker. This process continues until all 20 students in the class have touched the lockers. So the first question here, our first statement really, says create a representation to show what you understand about this problem. And the second question says, how does this representation show lockers? So how could we, maybe using these 20 rectangles here listed 1 through 20, how could we use that to keep track of what lockers are touched, how often, etc.? How can we keep track of what's going on here? 1 through 20, every single kid touches their locker for their number and does a skip counting for each of those, for whatever it is that they are. How can we keep track of that? What do you guys think? How can we represent this game that they're playing on paper in a diagram? Miguel?
We can just we can write squares in rows, and then we can go 2 by 2s and then 3 by 3s, but at the same one.
So you mean mark off as we go?
Yes.
Okay, could we use this these rectangles here?
Yeah.
As our diagram? Does that work for you, or do you want me to draw a new rectangle?
That one's fine.
This one's fine. Okay, so if I were the first student and I touch every single locker, what mark do you want us to use, Miguel? What's something quick and easy that we could mark it with?
A marker.
So like an X or something. Does that work for you?
Yeah, like a little dot.
Let's do dots. Okay. So let's mark the first student. So we have 1 dot there, there. So every single locker gets touched by the first student, right? Because we're skip counting by ones, essentially, is what's going on. All right, very good. Well, now let's look at the second student here. I'm going to change my color to green now, just to, I don't know, just to mix it up. So if I started at the second one, and I'm putting a Post-it note on every other locker, right?
Yeah.
So I'd start at 2, and then I would count by 2s and land on 4, 6, 8, and so on. So every other locker gets touched. Now remember, I want you guys creating this diagram along with me, okay? In your workbook or in your packet. We're going to be putting quite a few dots on pages, and I want to make sure that you keep track of it all, because you're going to use this diagram in your homework. So the first student touched every single page or every single locker. Second student touched every other locker, starting at 2. What lockers would the third student touch?
Wait, do I have to speak?
You can, Miguel.
Oh. The third student has to touch each third of the locker.
So every third locker. So if we're starting at 3, which lockers would I touch?
3. 3 and then
So
6.
Mm-hmm.
Ah, my screen turned off.
So 3, 6. You said your screen turned off? Do you need help from someone else?
No, I'm fine. It's because it always turns off, and then sometimes it takes forever to turn on.
Gotcha. Okay, so you have 3 and 6 marked.
9.
9, okay.
12. 15,
Mm-hmm.
18,
Yeah, 18. Any other
And
ones?
21.
Yeah, so if we're cutting off at 20, then there's no more, right? Because the next one would be 21, like you said.
Yeah.
Okay, so we did all of 3. Let's move on to 4. Can someone help me mark all the lockers that the 4th student would touch?
I'm just going to mute my mic.
Someone help me with the 4th student. Giovanni?
The 4th student would touch 4, 8, 12, 16,
Mm-hmm.
and 20.
20. Very good. Thank you, Gio. Okay, who can help me with 5? I have to start over on colors. Okay, I'll start over. Alan, you want to do this one?
The 5th student would touch 5, 10, 15, and 20.
Thank you. Ariana, do you want to do 6?
They would touch 6,
Mm-hmm.
and 12, 18.
Very good. All right, what about 7? Who wants to do 7? Miguel, do you want to do 7?
Yeah. 7, 14.
Okay. Thank you. Who can do 8 for me? Gio, you want to do this one again? You can do 8.
8 and 16.
All right, so only 2 for that one too. 8 and 16. Great. What about for 9? Alan, I'll go back to you. I see your hands up.
9 and 18.
All right. And then the last one that has 2. What about for 10? Stephanie, can you give me the ones that we count for 10?
10, 20.
Yep, 10, 20. Great. Now, for the rest of these, 11 through 20, would we mark it twice or only once when we count for this group, for 1 through 20? Would we land on any other numbers? Or would we grow too big out of 20?
What do you mean?
So we filled 1 through 10, right? We had all of the skip counting by 10. For 11 through 20, how many times will we skip count for this page and make a mark?
Let me see.
So if we were to skip count by 11, we'd start at 11, right?
Yeah.
What's the next number that we'd skip count to?
22.
22, and that's off the screen, right? That's over here.
Yeah.
Yeah, so all of these 11 through 20, we'll only put 1 dot down, right? Because if we try to skip count by them, we land way over here between 20 and 30, or even 30 and 40. So for the rest of these, 11, 12, 13, on through 20, we need to put 1 more dot on the top of them to count us counting the first one, like counting 17. But then when we skip count by 17, we land in the 30. So we're out of the question there, out of showing it on here. Does that make sense? I didn't really describe that well, but
yeah,
you see
makes
why
sense.
we have. Okay, so I want us to put 1 more dot for 11 through 20 is basically what I'm saying, because we're trying to skip count by 11 through 20, but when you skip count by it, we're going to get greater than 20, and we don't have a locker to mark.
Yeah, I get it.
Okay, so everybody should have this kind of representation or something similar that they can use for their homework this evening. Okay, because the homework problem that we're going to do is an extension of this activity here. So I will take a screenshot of this and I'll post it into Teams for you to view attached to the assignment, so you can help. You can get some help there. Okay, so I'll give you maybe a minute or so more to copy these down. And like I said, I'll take a screenshot of it and I'll put it in Teams so that you can see what we did. Okay, I'm gonna scroll down now and get us a good look at the homework before I let you guys go. Okay. So I'm scrolling down. It'll be 2 pages over. So page 25 in the packet or page 27 in the book. The instructions, the title first and foremost, 6.2, an open and shut case. The instructions are the exact same as the activity that we just did. It says the 20 students in Tyler's 4th grade class are playing a game in a hallway with 20 lockers in a row. Your goal is to determine which lockers will be touched after all 20 students take their turn touching lockers, right? That's what we just did the last 20 minutes or so, was walk through how we could diagram that, how could we keep track of it, so that now for this activity, we can start diving in and using that information. Okay, so the questions that you'll be faced with, which locker numbers does the 3rd student touch? Which locker number does the 5th student touch? Right, so just keeping track of which numbers that, or which lockers that student is slapping a sticky note on or touching. And then there's questions like how many students touched locker 17? So it's your job to go back and count the dots that we put for 17, explain and show how you know, talk about which ones were touched by only 2 students, explain how you would know, right? So just revisiting that model that we created, right? There should be a couple more questions about lockers that are touched by 3 students, which lockers are touched the most. You can leave 7 blank. You don't need to do 7. It says which lockers are still open at the end of the game. Since we didn't do open and close like it asked us to do, we just marked what was touched. You don't need to do 7, okay? Okay, so I'm going to stop sharing my screen here. Are there any questions on this assignment? Does this make sense? What we did to diagram who touched what locker, or we didn't really mark who touched what locker, but we marked which lockers were touched and how many times. So now it's your turn when doing that homework to keep track of what lockers a certain student touched, how many times a certain locker was touched, and so on. Okay. Are there any questions? Miguel, I see your hand. Miguel, do you have a question?
Yeah, I wasn't able to do it because I couldn't find any paper.
As far as following along?
Yeah, I was able to follow along. I just couldn't like find any paper to like write it on.
Okay, well, I'll take a screenshot of the dots and things that we did, the diagram we made, and I'll put it in the either in the chat or in the Teams main wall that we have.
Okay.
Where the assignments. Okay.
Okay.
Any other questions? Nope. Okay, I'm going to stop the recording.